we know for previous years, we've talked about it on this show, that the radar coverage in western North Carolina, the portions of northern South Carolina into the Piedmont of North Carolina, just doesn't have the best radar capabilities in the lowest levels. Well, the government passed a law a couple of years ago talking about how major metropolitan areas, Charlotte was mentioned in that, needs adequate radar coverage. So a case study and some information has been shared, and we got some release information on that. Jared, you like to talk about radar, so I'll let you kind of talk to our followers of what we are anticipating, and then I've got a few graphics that we can pop up and kind of put the words to pictures to show you just how excited we are about this news.
Yeah, absolutely. I'm going to take my screen full here. I'm going to show you guys just a brief little primer about what's going to happen here, because this is super cool. So this is a radar beam. This is a typical radar beam, and you know, when you get a WSR 88D next rad radar, this is what we use, what everybody uses: TV, NWS, us here at Carolina Weather Group. It scans at multiple heights, and it'll go, it goes certain heights and get a big volume of data. Now, the problem that we've had in parts of the Carolinas is that the radar site, when it gets further away, two things happen. One, the beam goes higher and the beam widens, so you don't get quite that high resolution that you'd like. And so in the case of places like Charlotte, where the 88D is either in Columbia or is in Greenville, which is 50, 100 miles away as a crow flies, you start losing some of that definition in the radar. So one of the cool things that is being investigated now is the ability to run at a lower tilt. So typical WSR 88D radar, its base sweep is at 0.5 degrees. Well, that's so the antenna is tilted up 0.5 degrees, and that's where it starts. So what they are experimenting with is, and this is what's being investigated now with the environmental study, is lowering that angle to 0.2 degrees. And that has some really neat impacts for radar coverage for some of those areas that are less served without having to put in another WSR 88D. So Scotty, you forecast up in the Carolinas. Evan, you can chime in on this too. In North Carolina, there's several radar holes up there. I'll be curious to know you guys' thoughts on these potential changes.
Yeah, definitely. And James, I know you're putting those up. So is this the 2000 or the 5000?
This would be the 5,000 adjusted. Yeah.
So as we're looking into the sky, this is 5,000 feet above sea level. The red circle or semicircle, and then all these little weak, crazy lines just because of the mountains, that is at the half a degree tilt. Now, the lighter the blue is now at the 0.2 of a degree tilt. So you can see at 5,000 feet, we're going to be able to see the atmosphere, what's happening 5,000 feet and below, what's happening in the atmosphere. So that's really going to be helpful. This is going to include places in the far-reaching areas. This is like Stanley County and Union County, Montgomery County, places like that where we didn't have the best radar coverage from GSP, but now we do. And if you go to the 2,000 feet, I think I sent that one as well. So there's the 2,000 feet. You can see that red circle. Great coverage for northern South Carolina, but as you get into the mountains of North Carolina, Asheville totally left out. So this blue line is the new 2 degree tilt, and as you can see, places like Charlotte, Concord, Hickory, up into Marion and Morganton, out towards where Chris is at in Columbia, the radar is going to be able to scan at the very low part of the atmosphere. This is 2,000 feet above sea level. So this is the very lowest part of the atmosphere that we wasn't able to see with the 0.5 degree tilt. So normally, guys, I'll bring Chris in because I know you chase a lot and use radars, and Evan, you live up in the Asheville area. Normally, if we see tornadoes, they're not happening 5,000 feet above in the clouds. It's right at the surface. And Chris, this is going to be easier for you to detect as you're out on the road. And Evan, this is going to be really useful for you guys in the Asheville area.
Absolutely, Scotty. So just to talk a little bit about that, when you're looking for a tornado on radar, if you're looking anything above 2,000 feet to 5,000 feet, unless you just have, one of them once in a year type EF4, EF5 tornadoes that rarely happen here, you're not going to see it. I mean, you can see mid-level rotation in a storm at that height, but you're not going to see the actual velocity data that indicates a tornado. And so by doing this and increasing the coverage, it's going to be tremendously helpful to all kinds of entities, not just the National Weather Service. All down the whole scope of the weather enterprise. But something else that's going to be really awesome is increased coverage across like northern South Carolina, southern North Carolina, really in that corridor between Charlotte, Monroe, down toward Rockingham, northern Chesterfield, Lancaster County in South Carolina, and really over toward the Bennettsville, Dillon, and Laurinburg areas of North Carolina before you get to Fayetteville. That's part of the, big hole in coverage also. So it's going to be really, really helpful for a lot of people and really beneficial to, thousands and thousands of people.
Yeah, we don't get many tornadoes in West North Carolina, but radar holes are certainly a big issue for us. Once you get past the mountains near Tryon and the North Carolina-South Carolina border, there's not very good radar coverage. At least there hasn't been in the past. Oftentimes you have to use a second tilt, which I'm not sure what that is in degrees. Somebody might know better than me, to see just up and over those mountains. And at that point, you're looking higher in the atmosphere where readings may not be as reliable as closer to the ground where the real rainfall rates are. So this will be exciting to have. It's always great to have better radar data. It rains a lot in Western North Carolina, as we saw last year. So it'll be useful for flash flood warnings. And we had flash flood emergencies last year. So hopefully we can use this to help predict those and real-time forecast those.
Definitely so.
Oh, sorry, Scotty. I was just going to say the second tilt on the radar is actually another degree higher. It starts out now at a base tilt of 0.5 degrees, and then the second tilt is 1.5 degrees. So, the lower that you can scan into any storm, it's going to give you better data about what's happening at the surface, which really matters because that's where we are.
Definitely so. So GSP, the radar out of Greenville-Spartanburg, the Columbia radar, I think is going to a 0.4 or 0.3. I can't remember. Maybe Chris can help me on that. And I know Raleigh, the KRAH, is also going to be at 0.2. So that's going to really help places like Charlotte, Greensboro, Winston-Salem, just because there's that hole in central North Carolina, the Northwest Piedmont, that just doesn't have adequate radar data. So that's going to really help us out. And I guess it's honestly cheaper than building a new radar. So this is going to be very useful to us. So if we can't build a new radar, at least we're going to get a lower scan, and that lower scan is really going to help out, especially in severe weather season, and as Evan was talking about during heavy rain events. So exciting news, and we can't wait for that to get in place and get started. So we'll continue to update you with this information. Like I said, this was just released today, so we'll get some more information on it as we go throughout the coming weeks, and hopefully here in the near future we'll have some better radar coverage for the Carolinas.